Hey, so I want to talk about my invention, my next project. You got me a couple of vane pumps here. They're fuel transfer pumps. These are dual direction. I got them at Harbor Freight. It was about $100 for both of them, which was very cheap. I mean, I was happy to get them for that. They're substantial. They're a very cool design that transfers fuel very, very, very efficiently, very good. Now, what I propose is to make one of them a sending unit and one of them a power transfer receiving unit. And so what I'm going to do is make a closed system, fill it up, and when I pump the one, and if you can imagine having another crank on the other side, which that's another nice thing about these pumps, is that they're kind of reversible. See, I can make a shaft all the way through set up using the two of them as one, which that may end up being the receiving unit in the finished deal, which is going to be a tricycle, a hydraulic tricycle drive system. And if this ends up being, if this one ends up being the back end motor, if the seal and whatnot mechanism, I'm going to make another video here dismantling them so I can show you how they function, and before the assembly and whatnot. Anyway, it'll have it could be the whole rear axle, differential, everything. Imagine this with a shaft going out the other side, which would be this cover put there, and a new shaft installed basically all the way through, and a crank on both sides, a foot crank. Okay. And so if you can imagine that. Now then, it won't be a foot crank on it though. That'll be the front unit, which will be about 4 times bigger in displacement. And it's all about displacement, the way these pumps work. They're a variable displacement. That's the neat thing, is that in my finished deal, the front mechanism will have inside of it a movable outer barrel, which determines the displacement of the pump, which determines its power and speed, its volume and its pressure. And so this can have like a high and low range and everything in between in a variable manner. Now then, imagine this with a shaft coming out, like I said, and this is the rear, so it's the rear axles, so it won't have a crank on it. It'll have a ratcheting mechanism on both sides, and that'll provide a differential, a positrack differential, which will separate the axles so that one can turn faster than the other. If you understand me okay there. So that'll provide a really nice differential, positrack type differential, out to the wheels, and even maybe suspension. There could be a CV joint in there too, I don't know. Anyway, and yeah, that'll be the rear differential, the rear hydraulic, hydrostatic, whatever, the sending unit to the receiving unit of the pump, which will be on the front, and it'll have the cranks on it, and it may have variable displacement. They could both have variable displacement in my final assembly. If I use these, it won't, because this is the way it is, and a variable displacement thing is a whole tricky animal. Anyway, they're vane pumps, and they're one of the most efficient ways. And I know that they already have, I know they already do this stuff. I know they already have it, but I'm going to put the application to tricycles. And I'm thinking that with the 4 to 5 times greater volume, just like you have a bigger sprocket on the front Then on the rear, if you can see my drawing there, I'm thinking about a 5-to-1, 4-to-1, or 5-to-1 ratio in displacement between the front unit, the sending unit, pump unit, and the receiving unit, the rear differential, I'm going to call it. And anyway, then it'll have the capability of going fast. 5-to-1, it technically, theoretically, it should turn this one 5 times every time this turns once, approximately, with no load on it. Now, that's the thing, is when the load goes on it, that's when the hydraulic effect will apply, and it'll provide power in a very smooth way and increase the power by increasing the pressure against the load. If you can see that the hydraulic effect will have a variable drive system just in that, in which liquid doesn't compress, so the pressure, it makes a big difference right away. It's just like your automatic transmissions, hydrostatic. This is a hydrostatic drive for a tricycle, for my next tricycle, is what I'm talking about. And yeah, these here are neat, very beautiful design. I'll show you when I tear them apart, but I hope it works because I really love the design. It has a large barrel, a smaller rotor with a slot through it, and a single vane going through it that's the full diagonal length of the barrel. And the rotor is smaller and offset, and that's what creates the displacement. If you look, it's not centered here. This side represents the displacement. And when you pump it, the fluid goes in the bottom and around and is pushed out the top. And it'll be going to the receiving unit. And now see, it's going to be a lot of fun. These are dual direction, which is very nice. So I'm going to find out which way they work the best. The inlet is bigger than the outlet on the functional fuel transfer system. So, but it may work better in this drive system in reverse, and it may work better one way and one the other way. It's going to be very interesting. It's a lot of fun, so much fun. Anyway, I wanted to tell you what I'm doing. The next thing I'll do is I'll do a little video after I kind of open these up and tear them apart, and show you the inner mechanism before I've got to make a trip to Lowe's. It's raining like crazy. And it's been raining. It's going to be pretty muddy, but I'm going to open mic tonight, and so I put my I have a rain curtain on the trike, so I'm going to put it to the test this afternoon and ride in the rain, see how that rain curtain works. So that's going to be fun. Anyway, I wanted to get my first video made of what I intend to do, and I'll try and give you little videos along the way of my progress. Eventually I see these being mounted on a board with basic hoses and a fill system, because that's all I need to do is basically close the system, seal it up as best I can, and fill it, and then try it. And then if I need to, I can mount it all down to a piece of wood, so that I can really put some force on it and see what kind of force I put in and what kind of force I get out. And that'll be it's a proof of concept experiment. And one part of it may actually end up on my drive of my tricycle, depending on what I can figure out here. So, ain't that cool? Is that cool? Okay. Okay, well, I disassembled it, and very simple. This is the rotor. I was under the impression it only had one that slid all the way through, but in fact it has two of them, each one on springs, and it has a seal, an adequate seal on the output. Now, so my rear end will have, if I do it, will have this over here, And this will have a shaft on this side just like that side. And whatever it takes to do that, I may be able to just basically bore this one, install a shaft somehow, or have a new piece manufactured, or manufacture a piece. That's what I need, though. I'll have the axle on this side just like that side, and that will be my receiving unit. Now then I'll show you how it is compressed in there, and it goes in the seal hole. And you can kind of see the function of it there. As it turns this way, the fluid comes in the bottom and is sucked as this opens up, as this turns, which I with one hand I can't do this with a camera, but anyway, if you can imagine, it comes around and this opens up and it pulls the suction. That's another nice thing about these pumps. They pull and push, and so they'll actually, that's why they'll pump out of a barrel real nice, because they'll actually self-prime and kind of suck the fluid up into them, depending on the viscosity. Now my goal is I'm going to probably use like vegetable oil is what I think would be ideal, as long as I've got a nice seal system and everything. And like I said, that shaft will be coming out of here, and this end plate will be on there. That's all later on. Right now I'm going to put it all back together, pipe it all up and fill it up, and try the proof of concept and see if I crank one if the other one turns. And if that functions, then we're on our way. All right. Okay, well, I got it back together. I ended up having to take it apart and check it. The alignment has a spring in there that divides the two vanes, but it's working real good. I can't hold it and turn it at the same time, but anyway, I love it. Everything's ready to go. The next video, I should have hoses and be connecting it up, and the fill system, and filling it up and trying it out. So that'll be the next step. God bless us, keep us all. Oh, an open mic tonight too in the rain. That's going to be fun.